Hi everyone, this is Jun Rao from the Bay Area. I'm one of the co-founders at Confluent. So today I'm excited to present you guys a new platform that we've been building, which we call Data in Motion. So what's unique about this platform is it's powering this new wave of integrating all the world's data in real time, and then being able to build event-driven applications on top of this real-time data. So you can act on that and react on that to help improve your core business. Another thing we have been building at Confluent is to offering this data in motion platform in the cloud. And we'll also be talking about what are some of the things we've been doing in the cloud to make this platform more cloud native so that we can accommodate not only just the real-time portion of the data, but also the historical part of data to offer a more holistic platform to our users. So if you are new to this space, you may have heard that this data in motion platform was really powered by Apache Kafka. And Apache Kafka is one of the most popular Apache open source projects there. It's used broadly by hundreds of thousands of organizations across the world and across industry, including some of the largest Fortune 500 companies. And if you look at some of the usage in terms of machines, bytes, the numbers are pretty impressive. So how did this technology get started? Well, some of you may have heard that Apache Kafka was originally started at LinkedIn. So I was fortunate to be able to join LinkedIn at a time when it had fast growth. So when I joined LinkedIn, it had around 600-ish people. In the short 4 years when I was there, the number of people and the amount of business grew by a factor of 10. So if you look inside, what's really powering that fast growth of LinkedIn? It's all about LinkedIn's ability to leverage its data. Today, I think every company seems to be talking about being data-driven, being digital first. But what's unique about LinkedIn is it had a couple of pretty deep realization about its data that allowed it to have this deeper level leverage of its data. And the next I will share what these two important realizations are with you. The first realization LinkedIn had is this, which is leveraging data in motion is a much effective way to leverage data than leveraging data at rest. Now, what do I mean by that? Traditionally, if you are using a data at rest system, when something in the world interesting that's happening, so what you do is primarily just to record that fact. But the leveraging of that new information typically happens much later and often in a batch way of doing things. And what LinkedIn realized is this is actually not a best way to leverage data. I think in a lot of LinkedIn use cases, they want to leverage data almost immediately as those interesting events are happening. Now, let me put that into context into how this helped with LinkedIn's internal services. On the right, you will see a bunch of those services provided LinkedIn. At LinkedIn, there are hundreds of those microservices that together they build a website. For example, it has an email service that try to look at all the interesting things that's happening in your connections and I try to send you this email digest about what's interesting happening in the world, right, around your close friends. It also has this recommendation engine, which try to recommend other members that's not in your connection yet, but these are the people you may be interested in connecting to for various reasons. It also has a service that provides real-time search. So whether you want to search for people, whether you want to search for company, it can provide this customized ranking of search results that's relevant to you. All of the services, you look at that, they are actually taking advantage a lot of data LinkedIn has. For example, if I change my job, right? So that information needs to be incorporated into all those services because all those services try to take all those information and massage that in a different view so that they can present those results in a much more insightful way back to the user. Historically, all those services were built using what we call this at-rest systems. So when something interesting like a job change happens, the information of when this information is incorporated into the services happens in the batch way. A lot of times, it's every week, or maybe sometimes it's a monthly, or maybe sometimes maybe daily. So what LinkedIn realized is to really make an engaging application, we need to change that. Instead of doing this in batches, we want this information to be reflected in those services immediately as they show up. So over time, all those services will change to be event-driven. So when an event like a job change happens, it will be flowing into those systems almost immediately and being reflected in those systems. So what's the end result of making this change from data at rest into data in motion? Well, the end result is all those services much engaging to LinkedIn's user because the information they have is much fresher. So this is the first realization I want to share with you guys, which is leveraging data in motion is much more effective way to leverage data than the traditional leveraging data at rest. The second realization I want to share with you is this, which is the need to leverage all digitized information. Now, what are all the digitized information LinkedIn has? Well, historically, LinkedIn most looked at what we call this transactional type of data. These are the information about your profile, your educational history, your connections. These are the information you typically store in a transactional database. But over time, LinkedIn just realized in terms of data, this is actually only a tiny portion of the data LinkedIn has. Because if you click on a link, right, if you type in some keywords at LinkedIn, these are not transactions per se, but in terms of usefulness, they are actually as useful as those transactional type of data because they carry very strong user intention. But in terms of like volume, those non-transactional type of events are easily 100 to 1,000 times bigger than those transactional type of data. So if you want to be a data-driven company, you can't just say, I want you only focus on 0.1% of company's data, right? So because you want to leverage all the data, whether it's transactional or non-transactional type of data. So this is the second realization LinkedIn had. With these two realizations, when LinkedIn looked at its infrastructure platform to see what are the infrastructure platform we can use to build these to help with these two realizations, you just realized, surprisingly, there's actually no good infrastructure for both realizations. Now, why is that? Around that time, there were two popular platforms people typically build applications on. The first one is various databases. Now, if you look at the database, the problem was that all those traditional databases, they are really designed for data at rest systems. When something interesting happens, they primarily just focus on storing them, but the leveraging of data, as I mentioned earlier, typically happens much later. The second platform people typically use for building applications, various messaging systems. If you look at those messaging systems, they are indeed designed for data in motion. So if you push something into the messaging system, you can consume that in real time and act on that as those events are happening. But the biggest issue with those traditional messaging systems is they are really only designed for a tiny fraction of all the data. They are mostly designed for transactional type of data. And if you want to flow 100x or maybe 1,000 times more data to those systems, a lot of them just stop working because that's not what they are designed for. With these mismatches, to really have these two realizations LinkedIn want to have, we really need to build something new. So this is how Kafka was born. For Kafka, what we really want to build is a new platform that can truly treat data in motion as a first-class system and can handle the data at scale. And I'll talk about some of the components we have been building over time. At LinkedIn, we first started building the storage part of Kafka. The first thing we have been doing is to make a data structure, what we call commit log, as the core way of how we store the data. So this makes it easy for data to be stored in real time and then delivered to real time to trigger actions for the applications. The second thing we did is to make the storage part really scalable. In the first version of Kafka, we have a distributed system to start with. So we have typically a cluster of those brokers and those commit logs I mentioned earlier. There will be hundreds of thousands of those, and it will be spread evenly among those brokers. And together, they can jointly use all the available computing resources, whether it's CPU, storage, or network. And over time, if your business changes, and let's say you want to accommodate for more amount of data, it's also easy because you can add more of those brokers, and together you will have more computing resources that you can use. So after building the first part of the system, eventually we open sourced Kafka to Apache Foundation. That's where we saw significant growth in adoption of this technology. At that point, we realized this is actually technology not just for tech companies like LinkedIn. It's actually a technology that could be used by every company in the world across industry and across globe. That's how we left LinkedIn in 2014 to start Confluent, where we want to truly focus on building this data in motion platform for the enterprises. At Confluent, we built a couple of components to make this platform more complete. The first thing I want to talk about is the integration part. So if you're a company like LinkedIn, you will realize that over time, you would have accumulate different data sources and data sinks. So the first thing you often have to do to really leverage this data in motion platform is to have all those siloed data integrated together into Kafka. It's kind of tedious to have every company to build a little bit adapter, right, to each of those common data sources like Oracle, SQL Server, or maybe some messaging systems. So what we have been building is an integration layer framework, which we call the Connect framework. With this framework, you can build those connectors that adapt to different those popular data sources and the data sinks. And over time, the community and the Confluent, we have built more than 100 of those kind of adapters. And together, they can integrate all the data sources together into Kafka. And from there, you can flow the data to any of those popular data sinks as well. The last part I want to talk about this platform is the processing part. So earlier I mentioned a lot of use cases of Kafka is really for people to build this next generation event-driven applications. So what those applications will be constantly listening to those event changes and then transform the data in a different view so that it's easier to derive new insights for the business in real time. And if you look inside what those microservices typically do, they have some pretty common patterns because often they want to take an event, maybe transform into a different format. They may also want to enhance the data, right? Doing some enrichment by bringing some additional metadata. Sometimes they may also want to do some aggregation over some time window. To make the building of those event-driven continuous processing a little bit easier, what we have been building is two kind of processing capabilities to make the building of those event-driven applications easier. The first thing we added is called Kafka Stream. This is a Java library. It offers some higher level abstracts that allows the application developer to specify some of those common processing patterns like filtering, projection, and then joining easier. The second component we have added from Confluent is called KSQLDB. This is a more declarative layer. It offers syntax that's very close to SQL, but it allows you to define some of the common patterns that I mentioned earlier, such as joins, filtering, projection, aggregation in a much higher level. So that way, even if you are not a core Java developer, you can use this component to define some of the processing in real time as you want. So with all these three components I mentioned earlier, we now have a complete data in motion platform. In the middle, we have our storage system that allows us to store and deliver data in real time, and also store and deliver data at scale. With the integration layer, we can connect Kafka with the rest of the ecosystems in the world, whether it's getting data into Kafka or getting data from Kafka into other systems. With the processing capability we have been adding through KSQLDB and Kafka Stream, we are providing those building blocks for people to build this new type of event-driven applications that allows them to accommodate to user needs in a much more real-time way, and that allows people to get insights into the business in a much engaging way. So with this platform, over time, we have been evolving this platform through various capabilities and features. So now Apache Kafka is sort of becoming this standard if you want to do anything data in motion. But what's next? What's the next innovation in this platform? Well, for us, we believe the next innovation in this space is going to come from the cloud. And we had our first-hand experience in this space. Initially, when we built company of Confluent, we are mostly just doing things on-prem. We are selling our software, but our users have to take it and install it and the monitoring, right, and operating it. But starting from a few years ago, we have been adding this platform as a hosted service, which we call Kafka Cloud. So why do we do that? Well, first of all, we believe this is actually a much better way of delivering the software. By offering that software data in motion platform in the cloud, we will be taking over as the operator for this platform. And anyone who has been operating a distributed system will know managing and operating a distributed system is not easy. So by having a SaaS provider taking over the operational part, we can simply simplify the adoption of this technology, which allows our users to focus on their core business. But offering this platform in the cloud is really just the first step. What we believe is there's a lot of like re-architecting that you can do in this technology to make it much more cloud native so that you can use the cloud resources in a much more judicious way so that you can provide an overall much better service. Next, I'll just share with you guys one innovation we have been doing in this space to make this data in motion platform more cloud native. So if you are familiar with Kafka, you will know this is how Kafka stores data today. We'll have a bunch of brokers, and each brokers have some local storage, and all the data will be stored among those local storage in all those brokers. Now, what's the issue with this architecture in the cloud? Well, there are a couple of issues. The first issue is in terms of cost, because if you look at this, in Kafka, we have two types of data. One is what we call this real-time data, right? This is actually where most of the applications are consuming because most of the applications want to be real-time. But for various reasons, most of the applications want to keep the data in Kafka much longer. This can be for fixing application mistakes or bootstrapping. So sometimes you have a large portion of historical data that also need to be stored. If you only have one type of local storage, that means you often have to use some of the more performing kind of storage, but are more expensive type storage, right, to store both the real-time data as well as historical data. So this will have implication on the cost. The second issue is in terms of elasticity, because since we have been coupling the local storage with the computing processing capability on the broker, it sort of makes it hard to scale out the storage need from the processing or the computation need independently. So, because if you run out of local storage, the only thing you can do is to add more brokers, but that just means you are overpaying the computing resources on those newly added brokers. So what we've been doing in the cloud is to re-architect Kafka's storage so that it can fit into the cloud in a more native way. So this is actually a new way how we store that in Kafka's data in Kafka Cloud, which we call infinite storage. So in this new architecture, instead of just having like one layer of storage, we're introducing two layers of storage. We still have the local type of local storage associated with each of the broker, but it's primarily used for only storing the most recent type of data. For the bulk of the historical data, we'll be archiving them to an external block storage. So you're familiar with the cloud. In AWS, this will be S3. And then within the broker, we'll only be keeping the references of those data to the object store. Now, what's the benefit of this new architecture? Well, there are quite a few of those. The first thing is in terms of cost. As you can see, because we have two types of storage, we can actually use the right type of storage for the right type of data. So for the more recent data, since we want that to be real time, we can continue to use some of the high-end storage for providing lower latency for this kind of access. But for the bulk of the historical data, they only need to have high throughput. So we can use those external object store, which offers much cheaper cost, but provides you good throughput. So this actually will make the cost much more efficient for this platform in the cloud. Another benefit is in terms of elasticity, because as you can see, by introducing this second tier of storage, we have truly decoupled the storage from the processing on the broker. Now they can truly be scaled independently. And if you have, for example, if you have some computation need, you can add more brokers, but you don't have to carry all those local storage with you together. And that allows us to do things like expanding the cluster in a much more efficient way. The last thing with this architecture is with this new change of how we store the data, we are truly allowing the data in Kafka to be stored infinitely at lower cost. Now, why does this matter? Well, this matters in that because it actually unified some of the benefits from the data at rest and the data in motion platform. Historically, a lot of people have this misunderstanding that for data in motion platform like Kafka, you only store the data for the recent data. You don't keep the data in this system for long because that's where you use the data at rest system for. But for a lot of business applications, often they need to access the data in real time in the common case, but occasionally from time to time, they also need to have the ability to access some historical data. By keeping the data, by having this capability to be able to keep the data in Kafka for much longer at lower cost, we allow those applications to be completely served just using a single platform, whether you're accessing data in real time or accessing some historical data. You can truly just use a single data in motion platform to serve both needs instead of having to use two separate systems, which will introduce this additional complexity in terms of operation. Let me share with you one example how this capability is being used in the real world. So the example I want to share with you guys is about a large custodian bank in the US. So what they have been doing is to use this data in motion platform to build what we call system of record. So what they have been doing is to extract all the core data they have from the core ledger, marketing information, investors, and they get all the information extracted and then store that in this data in motion platform. With the infinite storage capability, now they can customize for each type of data, how long you want to keep it. For most of the applications, they've been designing those applications to be event-driven, so they will be mostly accessing the data in real time. But occasionally, if they have application mistakes, or they may want to bootstrap a new instance of a particular application, they also need to go back to access some historical data. By keeping the data for weeks, right, in this platform, they can allow those applications to be bootstrapped and fix mistakes using the same platform. They're also offering the data to third-party vendors. By keeping those data in this data in motion platform for months, they're allowing those third parties to have much longer look-back window when they first get started. And sometimes they also need to do some batch reconciliation and auditing. By keeping those data in this same platform for years or forever, they allow this batch reconciliation and auditing to be done in the same platform. So this is the power of adding this cloud native capability for applications like this, so that they can build the system record using a single platform to power both the real time as well as the historical data access needs. To conclude, what we have seen in the last few years are two major trends in the IT industry. The first one is all the business want to move towards real time. When something interesting happens in the world, right? All those business want to incorporate that information into their core business as soon as possible. So as a result of that, a lot of the business are moving the applications from data at rest into data in motion. So all those applications are increasingly being designed as event-driven applications. So when something interesting in the world happens, this information will be flowing into those applications and triggering actions almost immediately as they occur. So this is the first thing we are seeing. It's just a lot of those event-driven applications are being built on those data in motion platforms. The second trend we have been seeing is a lot of the business are moving towards cloud. By having this data in motion platform hosted as a SaaS service in the cloud, we are significantly reducing the adoption, significantly reducing the complexity in terms of the adoption of this technology, because most of the business, they don't need a host and operate on this core platform. Instead, they can focus their resources on the core application business. By re-architecting this data in motion platform to be cloud native, we can build a platform that's much more cost efficient, that's more elastic, and empowering far more type of different use cases in this platform. So to summarize, in the future, we'll be seeing a lot of those event-driven applications built on those data in motion platforms in the cloud. With this, thanks everyone for listening and happy event streaming.